Welcome, Collective Nation, to another installment of the GENAI Collective podcast called Collective Intelligence. I'm your host, Thomas Joshi, ML researcher at Stanford, former ML engineer. I'm joined by my co-host for today, Chappie Azel, who is a software engineer at Apple, working on the AR/VR team. Just to remind you, the Collective Intelligence Community podcast brings the brightest minds in AI to the table to discuss the field's most pertinent topics. Each interview provides a unique perspective on this industry, providing sharp insights and informed commentaries shared to our growing community of founders, funders, and thought leaders. Today, we are joined by Aleksander Madry from OpenAI, on leave from MIT, director of MIT's Center for Deployable Machine Learning, co-lead of MIT AI Policy Forum, professor of MIT CSAIL. He has delivered testimonies to Senate Subcommittee hearings on topics including human rights and the law. We've talked a lot about taking ML from experiments to the real world. And I'm so excited to have Aleksander on the show because he's one of the world's foremost experts in deployed machine learning. So let's first talk about where you grew up, your education, and your prior work experiences.
Sure. Yeah. Thank you for inviting me. Happy to be here. My road here was maybe a bit unusual one and definitely quite winded. So I grew up in Poland, in a relatively large city of Wrocław, but then I got there in Wrocław my undergraduate degrees in computer science and physics. And the funny thing is that when I entered my undergraduate degree in computer science, science was the last thing I ever cared about. I thought that being a researcher is the most boring job ever. I wanted to program computer games. But, as I actually went with my friends to some more advanced classes, I started to actually enjoy what's going on there. And essentially by the end of my undergrad studies, I knew that I want to do research. And at that point, there were many roads ahead of me, but I realized, well, there were all these really cool papers that I read in my undergrad. And actually, unlike in physics or in mathematics, in the mathematics or at least more classical mathematics, these people actually are very much alive. They are at all the universities in the US. And I thought, how about I just go to the US to study with some of these people? And, I was lucky enough to get into a couple of programs. In the end, I came to do my PhD at MIT. So that's what I was doing for the next 4 years. After that, I had a brief stint at Microsoft Research. Then I was a faculty in Switzerland at EPFL. And then I guess the pool of MIT was too much. So I came back to MIT as a faculty, I was doing this for now, I guess, 8 years or so. And actually recently I went on leave and I'm spending my time at OpenAI. And the interesting part about all of that is that actually for most of my career, I did not do anything remotely close to AI. So I was actually doing a lot of theory of algorithms. So I was a theoretician, but essentially I guess by now in 2016, 17, AI was something that I really got interested in. And kind of as I explored it more and more and more, I kind of really transitioned to doing exactly that. Well, and yeah, here we are.
I'm curious how you found yourself. I think you said in Switzerland. What led you to abroad?
Well, essentially, after PhD, you want to look for a job, and I kind of thought there is maybe 10 universities that I would go for do a faculty job. If not, I would just go to the industry. And EPFL, at first, I did not know what this university is, but I said, okay, this was not something either on my list or off my list. This is just a new possibility. I visited there. I really, really liked it, and here I were. So yeah, it was quite unexpected. At that time, EPFL was only up and coming place. Now it's quite established, but yeah, that was quite a fun adventure.
Interesting. So thank you for giving us your background. Something that we always do at our events is icebreakers, just to talk about something that's not professional, not something about your resume, purely what your hobbies are, things that you enjoy. So maybe you could tell us a little about just a book. What is your favorite book you've read or movie you watched this year, and kind of tell us why it was your favorite?
Sure. So the thing about my job is that it's all consuming. So between family and my work, is everything kind of is a little bit about the work. And again, not because I have to, but because I just love it so much, and there's just so much to do. But luck would have it that the first time since pandemic, I was to a movie yesterday, actually on Thursday. Can you guess what was the movie?
Is this Oppenheimer?
Yeah.
Of course, it's Oppenheimer. So essentially, like, I was in San Francisco. I went with my OpenAI friends. Obviously, that's the movie too. Although apparently Barbie is the other alternative.
Yeah.
So that was actually like a very interesting movie, and in some ways it resonated quite a bit with me, especially both the development and the other development of atomic bomb, and also trying to do something about, okay, we brought this technology to the world. What actually we wanted, what kind of impact we wanted to have to the world, and how can we maybe modulate this impact? So again, the analogies are not perfect, but it definitely, like, it is a very good movie, but also it kind of nicely resonated. In terms of books, I kind of, so I also either just read some fiction, which is just to kind of, just relax before the sleep, or, I kind of read things, for instance, Chip Wars, like trying to understand a bit better the whole, I would say, societal and economical and political landscape of technology. So that's what I enjoy.
What type of books in that particular area that you come to mind?
Yes, so Chip Wars is just an example. Like, it's a kind of quite actually fascinating and surprisingly good book about like how all of the semiconductor industry it came to be. How the US used to be the center of it, but over time Japan and then South Korea become a center, and now why other countries, and Taiwan of course, and other countries try to become like a center, and they can. And it actually explains this is actually quite fascinating how extremely complex and specialized this whole business is. So that was kind of very nice that they kind of like it blends in the like personal history of the people who were kind of driving this field, and with actual understanding, okay, all these intricacies of the technology, supply chain, and again, government investment, and so on and so on. I found it quite fascinating.
Yeah, definitely. I read Chip Wars last month as well, and I would definitely love to dive into the role of government as it relates to technological development. We'll do that near the end of this.
Sure, definitely.
Thomas, back to you.
Yeah, so thank you for kind of giving us an inside scoop into what books you're reading and what's on your mind, and can definitely see how that kind of informs some of the things that we'll discuss today. But let's first get into your role as director of the MIT Center for Deployable Machine Learning. So, what exactly do you do from your perspective? Why do you do it? So why is it important to you? And then we'll kind of, and then maybe do some definitional work. Like, how do you define adversarial robustness? And we'll kind of dive into some of your work in more detail from there. Sure.
So there is a lot to unpack here. So let's go step by step, and you can always, try to essentially ask follow-up question if I skip something. So, deployable machine learning. So in some sense, this comes exactly from my thinking about machine learning, kind of, which is the most successful currently technique in AI. And actually, like my initial work, there was adversarial robustness, and we will dive into it in a moment. But the point was that kind of it made me realize something very maybe obvious in retrospect, was that as amazing as machine learning is, it's still not exactly the technology we would like to have eventually. Okay, it's extremely promising. There's a lot of really cool stuff happening, but it's still not the endpoint we would like to be. In particular, I ask, okay, so what are kind of, when I say deployable machine learning, I think, what kind of machine learning we would be happy to deploy? In a sense, machine learning that is safe, that is reliable, and we can deploy in a responsible way. And again, some of this touches on like this topic that I know quite a bit about, which is adversarial robustness. But then as you think about this question, you realize that this goes way beyond that. It actually goes even way beyond the core machine learning discipline. It touches on, both, of course, applied aspect of machine learning, theoretical aspect of machine learning. But then you think about programming languages. When you think about verification techniques, that's where the domain kind of has a lot to cover. Then you realize that much of this is about interactions with humans. So HCI, human-computer interaction, comes into play. And then you again realize that these techniques are developing in context of society. So you want to have, some knowledge about socio-technological challenges in that, essentially how law and kind of just, the way people work, it kind of blends into this technology. And then you realize, okay, that's the whole space you want to cover. Is there an area, a traditional academic area in the, kind of in ML or beyond that captures all of that? No. So you need kind of to do something new, something that tries to span these different disciplines to kind of blend together and focus on challenges. So essentially, you want to. This is my challenge. What will we need to get it? So that kind of led to this idea of the Center for Deployable ML, which I became a director. But really, again, it's academia, so everything is very democratic and very kind of, I would say, diffuse. Academics are loners by definition. But kind of what we did is we tried to say, okay, we all have, I got a bunch of my colleagues, we all have our things going, but we really wanted to start collaborating together and kind of go towards this goal. So we thought, okay, we need to design the mechanism that will draw us together to work. And it usually works best by collocation, but getting 10 faculty in one place is just impossible in the logistics of how things work. So we said, well, how about the next best thing, or maybe actually the best thing, is to get some of the students together. So essentially we found the space where we kind of had students of different faculty together. And that was the point, that they just hang out together, they talk about what they are doing, and they will come up with ideas and projects. And this worked actually quite well. Then the pandemic hit, and this space proximity was not something that was encouraged or even possible. So now we are recovering a bit from the pandemic mode. But this was this was both the motivation and the mission and the way to get there.
Then I guess, what are you most proud of, and what are the key achievements from your work there, or some of your research, the research that's occurred in your former lab, or sort of labs at MIT? Some papers that have recently come out are sort of model diff, a framework for comparing learning algorithms, and distilling model failures as directions in latent space. What are the common sort of themes and narratives that kind of tied together, or what are you most interested in answering?
Sure. So again, we are you are talking about 10 MIT faculty with a lot of brilliant students. There's just a ton. I will not even try. To be honest, I'm probably not even aware of of majority of the work. That's the reality. But what I'm most proud of from the point of the center is that there were papers that really span different people. I have some papers with people in vision about editing models. There are papers with between HCI and programming language people about thinking about thinking about generative models. There are papers about trying to figure out how to do health records better, electronic health records better. So all of this comes from collaboration between the faculty in the center. And again, in the end, I care much more about connection, in particular the fact that sometimes there was a paper between two groups where the advisors were only became aware of this only in the later stage of collaboration. So the students worked out most of the things, as it often happens, and just brought in the advisors afterwards. So all of this was really impact. Of course, I am familiar with the things that I am doing, and there is a lot. I have a very, very hardworking and very brilliant students. So I think one of the important themes that much of my recent work is about is essentially, I would say, data-centric machine learning. So the basic idea here is that, okay, our models, when we do machine learning research and when we think about machine learning, we think about models, right? Because they are the most visible emanation of all of these techniques. But if you think about it, yes, definitely we need to get the models right. And again, it took a lot of innovation to get there. But if you think about this, models are a tabula rasa. So they are just a blank slate. Okay, the knowledge of the world, a modular convolutional layers, which is some important prior, there is no knowledge intrinsically of the world in them currently. That's the way we do it. And instead, everything they learn about the task that they are supposed to solve and about the world in which they are supposed to solve this task comes from the data. So I realized that we might, as a community, not put enough effort to try to understand how the behavior of the model is impacted by the data that they ingest. So that's the common thing, trying to shed more light and build tools, the new microscopes that allow us to view that was a major theme in my work. In particular, here we have a work on data models, which essentially try to figure out attribution of a particular behavior, let's say decisions of the models, to be able, the model decides to classify this photo as a dog, and you're not asking the question of is it correct or not. You're asking what in the training data, what were the data points in the training data or data sources that were the most influential in the model making this particular decision on this input. So this is a way to really trying to do this data attribution, and it ends up to open up a lot of very, very, very interesting questions to answer. So you mentioned model diff, where essentially you have this completely new to me and like very exciting possibility of comparing two very disparate models. Like imagine you choose two different pipeline settings of training a model. Maybe you choose different learning rate schedule, or you choose different architecture, and you want to compare, which pipeline you should go with. In the past, there was only one decision saying, okay, I look at ImageNet benchmark or whatever is the task you care about, whatever gives me higher validation accuracy. That's the kind of, that's the model to go for. And again, it worked, like we got all the way here by just doing that. But like, is that really the only thing we can do, or the thing we should be doing, just like being so benchmark driven? So kind of now you can kind of have much deeper answers to the questions. Okay, what is the impact of the different choices by kind of model diff, which essentially tells you what are the feature biases that the kind of that the resulting models have depending on the choices. So that's what model diff is. There are other things that you can try to do with that. You can figure out how to kind of defend against data poisoning. So essentially, like someone tries to manipulate your data set to make the model kind of have some undesirable properties, and essentially that's that's something that that's something that we did with this with this framework. All kind of recently this is work that like is very, very recent. Is just if you think about diffusion models, like kind of which are kind of all the rage in generative AI, we wanted to understand. Okay, again, clearly the model that the images that the model generates, or the text that the model generates, it clearly comes from the training data, right? It's it's synthetic, but it's in some ways it has to come from data. So can we kind of attribute, in what way, like if there is a given given image, can we attribute what might have produced that? So anyway, so this is just like examples of questions that you are able to do once you have this kind of data model framework. Which, by the way, recently we have a track paper which makes it more scalable. So that's one kind of a big part of my work. The other one is kind of to think about distribution shift, which is again this is really the problem when you talk about reliability. Saying, okay, things work great in the lab where you develop your model, you put it in the real world, things not work. What to do about this and so on. That's kind of, we have really a few of the results I'm really proud of.
Right. So one, you bring up this point about data attribution. This is a very common point that people are debating right now, particularly for generative art and music. So if you have a generative system that takes sort of information on the web and produces sort of music, how do you go back and attribute that? As humans, we also kind of read text and we listen to music, but it seems that the human brain is more of a black box, and so we have a harder time assigning attribution, saying that this data point produces this output because of that, and so we kind of throw our hands up and say, what, there's no such, we don't, this is human creativity. I think we attribute that to human creativity. But I want to get into, you bring up some great points about distribution shift. A lot of our listeners are AI founders who are in the real world building. They have this model that came from open source, maybe, that performs really great. The architecture really performs great on a benchmark, but is having the exact same problems that you're mentioning, which I've had a lot, which is the real world has long tail distribution where there's a lot to accommodate for, that even if you did data augmentation, you tried to adjust your distribution, you still won't include in your training data or your test set. I guess, what are some key questions or principles that you'd have them ask themselves, live by, as they kind of wade through this uncertain world, either for AI infrastructure builders, applications, just some key principles for them?
Sure. So I would have a few thoughts. And again, I view this one of the key challenges in like reliable machine learning is to deal with that. So first of all, I think they need to accept that distribution shift is inevitable. Like, yes, you should like really try to do everything you can to have as diverse data set as you can. That's extremely important. But kind of you need to accept that you will always fail. Like, meaning, it's just by definition, the diversity of the world is just so much different, and we don't even get into situations where kind of there starts to be some feedback loops where the clients react to how your model works and kind of adjust what they show to the model and so on. So in some sense, this is inevitable. But so one important way, and again, I'm sure anyone who actually had to do with realize it by themselves quite quickly, is that we have this way of viewing machine learning as a kind of this, okay, I train my model, and I do this like all the sophisticated things to make it, robust, train it with different things, make sure to cross-validate, all of that. But then we say, okay, we train the model, now we just deploy the model and it's done.
Right.
And essentially this is just completely the wrong mindset to have. Like you always, deploying models is a service, not just a transaction, right? Because you need to, if you don't have like infrastructure to monitor the model, to retrain it as needed, you will never be successful. So every company like Tesla and like all the companies know that really what matters is not the initial model you develop, but the whole infrastructure you have to very quickly, repair and kind of retune the model as it enhances, as it experiences the real world. So kind of having this when you design your whole pipeline, your code base, having this in mind, like it's absolutely critical. Like you just have to accept that this is how to think. And once you are in this setup, there is a plenty of things to do. So again, I'm thinking about some ways of monitoring. So actually, like we have some work that like shows like a relatively simple but actually surprisingly effective way of trying to understand, is there at least some consistent distribution shift in the data you're observing? In which kind of what you do is like you observe as your model is deployed, and you observe kind of the inputs and whether it might be correct or incorrect on them, and kind of you want to say, okay, is the distribution shifting in some discernible way? And the way you can do it is by essentially trying to solve, let's say, the latent space of your model. Try to solve this kind of binary classification questions of, can I find, let's say, just a hyperplane in my latent space that separates the points that my model will go right versus the model that it will get wrong. So I don't try to guess the answer. I'm just trying, will my model get it right or will my model get it wrong? And what we demonstrated is that essentially if there is some actual like fundamental distribution shift, you can actually solve this problem, and you can start even, then you can like get fancy. You can like, if it's about images, you can do it all in the clip space. So we can even have captions that kind of try to explain to you what are the type of inputs that are bad. So essentially, like this kind of toolkit I am trying to develop in my group is exactly like, once you are in the monitoring mode, how would you kind of diagnose something is wrong, and of course, how would you feed this into intervention? How to fix it. But yeah, in the end, distribution shift is here to stay, which is fine. Like that's just a matter of the attitude and expectations.
So totally agree with your point on setting up your own separate ML infrastructure. In prior roles I've had where the ML infrastructure was, at least the deployment of ML model was integrating software teams, and not only do we have issues with kind of having separate iterations and needing to go at the speed of the software engineering team, but we also had issues with, how do we, once we wanted to go and set up our own ML infrastructure to do A/B testing and to do, to retrain the model with new updated data, you also had issues with decoupling the ML system. So now you have to re-engineer all the parts where ML was inside the original software engineering pipeline. It's just easier if you have that idea and concept from the start that these are two separate teams that you build for. That have different needs. Software engineering is going to be a very deterministic process and system, whereas ML is very experimentation focused. You really aren't sure about what the results will be, and so that's a very important philosophy to get right from the beginning. Moving on to your work as faculty co-lead of the MIT AI Policy Forum, can you just once again just give us some background, give us our audience some background on, what was your role, what are you most proud of there, and then we'll take it from there.
Sure. So this actually, like, it's a nice way to put narrative, because it actually spanned from my work on robustness of machine learning and this kind of deployable ML. Because again, I already hinted at it. It's just like you quickly, like when you start thinking about this as a problem, as opposed to trying to just have a hammer and looking for nails, you realize that again, it's not a purely technical problem. It's also about the people and the way the models are deployed. And kind of, okay, you step back and then you see two things. So first of all, you see that this is not about technology only, it's about technology and society and people interaction. But the other thing that you realize is saying, wait, this AI thing, like, again, everyone in the field, at least for the last 5 years, expected that, we are clearly having tremendous progress and things will just work. Even 10 years ago, you could see this, but like 5 years ago, it was obvious to anyone that work on this. But I would say people did not realize this means that AI will change all of society. And I mean it, all of society, like every facet of our life. Yeah. Even now already, it's permitted, like, essentially permitted, like it's kind of infused with AI, starting from loans, starting from our driving, like everywhere. Like even if you don't drive a self-driving car, or like you drive any car, there are already things that actually use machine learning to help with safety and so on. So AI is kind of permitting everything, but somehow the society didn't really notice. Like, they were all amazed by some things, but I think until ChatGPT moment, like it was kind of, yeah, that's cool. It's nice to read an article about that, but like that's not something it is about us. I think this is no longer go. But like what I realized is before ChatGPT, and I realized, okay, if this is about changing of all of the society, we as technologists, we need to think, what is the impact of the technology that we actually have? So we know we will have impact. We know it will change, but like, yeah, maybe we should care what kind of impact it goes. And there is this kind of saying that technology is neither good nor bad, nor it is neutral, which means that it always has some impact. And the way you deploy it, it kind of modulates that. And again, this is coming from MIT culture, and MIT culture is like, if there's technology you can build, just build it. Just build it and ship it, and that's your job. So kind of I realized, okay, maybe that's not the right attitude to have given what we are building here and how it influences the world. So now you say, okay, how do we modulate? How do we actually tell the world that they should pay more attention? And how do we make sure that this whole society gets more attuned to that? And that's when we realized, okay, well, it's time to talk to policymakers, but also NGOs and other stakeholders. So that's where the idea of the MIT AI Policy Forum came about, right? So we said, okay, what is academia good at? It's good at research, but it's good at teaching, but also it's good as being a relatively neutral, convenient place for a conversation. So we had, okay, so let's create this AI Policy Forum, which again, it's a forum where we will be bringing policymakers, civic societies, researchers, also industry, and try to say, hey, there are some important things happening that impact different parts of our society, our economy. How do we think about this? What are the emerging challenges, and how do we collectively go about, making sure we go in the right direction? So again, so that's the framing of the AI Policy Forum. And within that framing, we kind of had some task forces that look at specific domains like healthcare, mobility, finance. We also talk about AI in general, and kind of, I did actually a lot of work like motivated from this conversation. So this is actually the other thing I realized is that actually talking about this global problem is actually gives you an idea, because people ask questions, oh, can't you do just that? And you say, oh, actually, I don't know if you can. Now that you ask, it's actually a good idea to ask about it. In particular, some of the data model work came from this kind of realization that there are some questions, because there's a lot of this was about data and fairness. So anyway, so I kind of started to really learn and kind of try to realize that there is a whole space where dialogue is missing, and kind of that's what AI Policy Forum was about.
Okay, so that is a phenomenal. So we've sort of dug into creating the foundation of all your sort of future work or work that's come from that. We've talked about, okay, you're the Center for Deployable Machine Learning. We've talked about the faculty co-lead of the MIT Policy Forum. Now we kind of get into the good stuff of what you're doing with that platform. So Chappie, maybe you can get us started with that portion.
Yeah, definitely. So Aleksander, you've spoken to before a couple of governmental subcommittees about AI advancements. In March, you talked with the subcommittee of the House about AI advancements and risks. And in June, most recently, you spoke to the Senate Subcommittee on Human Rights and about the law. Could you do us a huge favor and summarize your kind of sentiments that you were conveying to both of those subcommittees, those testimonies that you gave?
Yeah, of course. So exactly, this was, of course, stemming from the activities in the AI Policy Forum, and kind of, after ChatGPT, everyone noticed that, like, okay, we actually should talk about that. So essentially, at this point, there was this first House subcommittee hearing, in which kind of was, at first, it was like, I would say, level setting, kind of like, okay, let's broadly talk about AI. So there in my testimony, so again, testimonies are, of course, you come in, you make an opening statement, and then you answer questions of the congressman. And but again, of course, the real value of a hearing is that it's public. So it's kind of a good way to bring some attention of the policymakers and beyond to certain questions. So in that first hearing, I kind of focused more broadly on different, like, okay, hey, AI is great, but there are some very, like, essentially trying to give them bird's eye view of what are the risks involved. One of them is essentially, okay, first of all, AI is happening. It's like, again, I think after ChatGPT, people didn't need to learn it, but like I just wanted to make sure it syncs, and it's no longer a thing in the research labs happening or somewhere in some startups or big tech companies in Silicon Valley. It's actually like happening. Everyone will be affected by this. It will be deeply integrated in our economy and society. So pay attention. And then I said, okay, yes, as usual, technology brings many promising opportunities, which I described, but also risks. And these risks are manifold, from like the more traditional risks of like discrimination, just lack of robustness and reliability, which people don't realize. They just view this cool, see this cool demos, and they said, this is magic, this works, and they're saying, okay, no, it doesn't work. Always ask about kind of the fine print of when it doesn't work, and actually sometimes we even don't know when it doesn't work, so that's even worse. But essentially, then also this was more in the context of generative models, like saying, one big problem I see in all of that is that kind of we really anthropomorphize this technology. Again, we were wired that anything that talks to us in natural language is a human, or or human writing or something. So once we have this device that talks to us in text, we just really think and try to apply our intuitions of a human. And again, that's something we need to realize we are doing, and realize that this might go very, very, very bad way, because again, nothing in our evolution or our societal evolution ever prepared us for anything like that, right? Like we just don't know. Like our intuition is essentially a liability here. And one context in which I really kind of wanted to mention is kind of say when this will play out is, again, like if you look at synthetic media, like essentially fake, deep fakes, phishing, harassment, all of that. When you have this kind of this technology, but also even education, like it looks so persuasive. We just say, okay, why do I need to learn anything? I can just add ChatGPT, and it actually does an amazing job at synthesizing stuff. Like I really use it myself. But the point is, you have to understand what's exactly happening. That these models are not reasoning; they are just kind of doing some, they're not reasoning yet. They are doing some reasoning, but like it's not the reasoning the way we would humans do. Again, by now maybe people, like it was in March. By now I think there was enough articles in the press to realize that they can make up stuff. They can be very persuasive in making up stuff and so on. But at that time, I really wanted to make sure it is heard, and kind of trying to really like give them realization like there are many not obvious dangers that are coming. And then also I said, okay, there are all these dangers, and please pay attention. But also there is a question of, okay, what will be the economic picture of AI once all of this happens, right? Like we will have this forming AI supply chain, and how will this supply chain look like? Will there be a few companies at the top, and then like upstream, and everything will go downstreams? Will there be like a ton of different companies, like fragmented supply chains? If you think about supply chains, there's a question of liability, a kind of assignment, like when something goes wrong at the downstream model, like how do you figure out why did it go wrong? Like it might not be that because of the downstream person did something wrong. There might be something upstream that didn't work. So again, this is meant to be level setting. So just saying, look, there are all these complexities that really, you really need to pay attention to. And essentially, that's what this first hearing was about. And it was actually building on a bunch of blog posts that my students and I and my collaborators did around this issue. So again, this was March, which again, like sounds like forever, honestly, in the grand scheme of things. And now in June, what happened was kind of, okay, now this was a bit more focused hearing, which was like about like AI and human rights. By the way, when they invited me, I said, well, I know things about AI. I don't think I know much about human rights, but like I said, okay, no, that's exactly like we want the AI experts. And also, I like after conversations with like what kind of topics they want to cover, like it became very clear that there is a very, very, very clear message that needs to be said. And this is kind of zooming in on the potential impact of generative AI on our information ecosystem. Okay, so again, think about this, is that like, like we all remember the the spam messages, like when the email became a thing, and with the spam messages, and again, at that time saying, oh, someone wrote me an email, it's clearly done in good faith, and this is coming from a human, and so on. So let me click on all these things or read this message. So we had scam, we had spam, we figure out how to deal with it. But now, with kind of AI, generative AI, this all went to next level. So now it's no longer about spam just send like as a mass thing. So in particular, as you know, the phishing attempts, they look obvious to us as phishing attempts. And the reason is because kind of it's not, you know, like it's not, or the scams, it's not beneficial for the scammers to make them too persuasive, because in the end, you know, there has to be whole follow-up play when you send the money or you download something and install on your computer. So you need to be viewable enough to even make it worth it. And usually the next stages like require human oversight, so the scalability goes down. So they say, let's make the message so obviously scam that anyone who actually clicks on it, clearly we have a very good chance of, you know, finishing the conversation. Having said that, I kind of almost fell for one of these attempts. So you see, so MIT professors also also do that. But actually what got me was, now what's changing is now you no longer have to do it at mass. You can make a very individualized, very targeted scam attempts, and kind of just, you know, I can look at your social media and essentially like, you know, customize a whole initial message that is kind of really persuasive to you, saying, you know, Chap, you know, Thomas, kind of, you know, I'm looking for the recording, you know, here is the link, here's the recording I have, is it the right recording, you know, from the podcast? And the scary thing is that you might not need any human intervention, not only to craft this initial message, but even to have all later the conversation with you, if there is like some more elaborate stuff. So that should give everyone a pause of, okay, so we are entering new era. You know, you can also imagine things like, you know, automatized blackmail at scale. Yes, you can imagine, oh, you know, with all this image editing software, I go to your social media page, I download a few of your photos, and then I synthesize, you know, your picture in some very compromising situation. And again, you know it's fake, but I say, I email you as a scammer saying, you know, unless you pay me 0.01 Bitcoin, essentially I will make them available. And again, you know they are fake, but now explaining to everyone that they are fake, like that sounds like a lot of really effort. So how about they just pay and just forget about this? And again, the point is that even if it works 1% of the time, the economics of this will still work because you can do all of this completely automatically, right? So again, there was the other construction. There was another witness. She had like, you know, she actually lived through the, you know, generative AI powered scam when essentially she got a phone call. It was essentially like it was pretending that like her daughter got kidnapped, and there was actually a voice of her daughter asking her, "Mommy, you know, like I'm scared," and so on, and just like it sounded like her daughter. It was actually all fake. So anyway, so I want to bring attention, like, look, there is something to think about. You also, you know, need to think about this. You can now mount all of the, like, you can campaign for a political office via phone calls. Like normally you need a ton of volunteers who are willing to call people on your behalf to ask for donations or for a vote. Now all of this can happen with using generative AI. So like I just wanted to really have this like very focused warning saying, look, we are entering a new realm. We need to work on this. And then, you know, here I kind of try to provide some of the potential solutions. Like some of this is my work, but there are many other kind of concepts that's saying, okay, the bad news is that this is coming. The good news is that we are not defenseless, but like we need to act, and some of the acting needs to happen by Congress. Like some of them is about policy. So that was what was the second subcommittee hearing about.
Awesome. And from the outset, when we were talking about Oppenheimer, we were talking about the importance of government in the development of technology, especially as you look throughout history with the development of semiconductor, that whole industry. So in your opinion, what does, in broad strokes, the role of government need to be in AI, in the advancements we're seeing here? And then in your opinion, are we able to move fast enough? Are we moving fast enough currently, especially given the exponential rate of technological progress? I see technological progress is only continuing to increase, while as we look at the rate of public policy and the rate that these changes getting enacted, it is either flatlining or moving down. So how are we going to deal with that divergence? Can we move fast enough?
Okay, so many questions again, which I love all of them. So let me try to address some of them in order, but like let me know if I missed something. So first of all, again, so Oppenheimer is a good analogy. There is a big difference to that, is that everyone knew what the problem is. Like everyone knew what, like, once the first, like, I don't want to spoil the movie, but he says, until we actually detonate it, no one will believe us. But once we detonate it, everyone knew what it's about. So the danger was very clear. It was very, like, everyone knew exactly what is the physics of it and what's possible. Even then, to be honest, it took a while to get any satisfactory solution. So that's kind of a working side. But like, the problem here is that we don't even know exactly, like, the whole frontier of harms and dangers and risk is only expanding, and we kind of don't really know. We are really still very much in the fog of fog of war here. So in particular, if you think about semiconductors, like the government first invested in them, and essentially they really, like, thanks to, honestly, DoD created the semiconductor industry, because it was for missile guidance and so on. It was all very, very defense oriented. Only later, the guy in Silicon Valley realized, wait a minute, this is good money, but this is just a small market. Like, if we can do the consumer market, that's things change, and that's actually where the government subsidies kind of subside, because okay, well, you don't do it for us, then good luck. We have an economy. We don't provide kind of support to economy. That's we believe in the market, and that's where actually Japan and later Taiwan kind of said, no, we actually want to subsidize this, because it's a very they just view it as an economic opportunity. But then the US realized, wait, first of all, this supply chain kind of became extremely specialized. And actually, again, there's still a lot of critical parts of supply chain in the US. There are some companies, this is what I learned from this book, is that, like, there are companies that actually knew. One of them actually sponsors the faculty chair I am in, but I didn't realize that they're owning one part of the chain. So it's not only they are part of it, but like, they are kind of bottlenecks. Of course, we usually talk about the bottlenecks in Taiwan or in Netherlands, which of course are, because they are kind of, one of them provides this equipment, and it's actually crazy how dispersed this thing is. And essentially there's one person, one company that does like the lenses for all of the industry. Like, anyway, but the point is that the US has some of it, but not only realizing, wait, this is also a question about strategic kind of aspects. And again, like, especially with AI, it became so important. So everyone wakes up. But like, the point is that we really don't even understand fully what all the risks and significance of AI. That's where we are now. For a number of years, US government kind of did not really do much, and the reason was saying, okay, well, if it's so important, we have all the big tech, it's all good, no worries about that. Only I think with just ChatGPT and kind of realization of, like, okay, how powerful this technology is, there was a kind of this wake up call. And now, will the government act? I think it will. I spent quite a bit of time talking to policymakers. It's very clear. Everyone cares. Everyone is interested. Everyone wants to do something. It's, by the way, a very bipartisan issue. Like, there is actually a lot of agreement. Almost surprisingly a lot of agreement between both sides. Very thoughtful people thinking about that and really wanting to do. Of course, from the desire to do something, to doing something, that's a bit of a longer walk. So that goes back, okay, will we do something? Definitely we do. Will we do it fast enough? That's the question I ask. We have to understand that, like, policy works in a very different calendars than technology. I think they kind of got the memo that they need to do faster than possible. So I'm not sure how much you are, following this, but at first, everyone wanted to do something about AI, and the problem wasn't then this. I think my understanding is that some of this kind of initiatives kind of block each other, is because kind of you need to have one. I think by now there is a coalition of senators led by Senator Schumer, Rance, Young, and Heinrich, that kind of said, okay, we will try to kind of coordinate this work, and in particular. In the fall, there will be a number of AI policy insights forum when they bring the experts. Like, they said, we want to move fast. Again, it's still a DC fast, not Silicon Valley fast, but it's there. So I would say that there is a progress, also because there is an EU legislation, there is China legislation. So there is feeling that this is kind of urgent. But yeah, I want to hope, this is me being optimist, and probably too much of an optimist, by next spring, we will have something in place. But again, this is possible, but I wouldn't say this is the most likely outcome, so especially with the elections coming in. But anyway, long story short, one thing that struck me is that there is a real interest of the policymakers in that. There's a lot of agreements that we need to do something. Again, once the details emerge, I'm sure there will be disagreements, as always. There should be, actually. And also, what I was impressed by is that the policymakers really want to understand. Like, they know they don't know, And in the past, they were like, okay, we don't know, maybe we should not be just meddling with this. Like, let just, let just these technology people do the stuff. I think now they realize, okay, no, we cannot just pass the buck. It is on us. So let's learn. Like I was actually, giving with my colleague, Professor Toralba, we were giving briefing to the House of Representatives on AI. So like all the whole House. Later on, Professor Toralba was also doing the Senate, Senate hearing, like Senate briefing. I couldn't because I was at OpenAI already then. So that's unusual. Like clearly, these people want to learn, and they really want to learn. Like they actually ask great questions, and they kind of clearly are, connecting their experience in policymaking with this new thing and trying to look for analogies. And so, it's exactly what they should be doing. So, I am optimistic, maybe cautiously optimistic, but I am optimistic. Now, will it be still fast enough? Probably it will be okay. Like I always feel that we should have done it 2 years ago. So, but it is what it is. So, but I'm hoping.
Sure. So that is one, encouraging, but two is it also creates, some uncertainty on, how can builders, researchers kind of fit into that story. So thank you so much for kind of giving those questions in the back of our minds. Maybe we can dive into, we've kind of talked about your experiences at MIT, your work in sort of forming policy and being a thought leader in DC. How does OpenAI fit into this world? I mean, what do you hope to work on? What problems interest you? And if there's any other details that you can share.
Sure. So essentially, OpenAI needs no introduction, right? So it was a little bit of thinking of saying, okay, I very much believe that AI will change humanity again, for better or worse, but it will change it. And I really view it as my responsibility and also opportunity to influence positively. So I did a lot of this work in academia, but if you think about like where AI is happening and kind of how to maybe now these experiences from academia, bring to bear in a more, I'm still a technical person. Like I like to, understand stuff, build stuff, figuring out stuff. So where can I have the most impact given the current climate? Like OpenAI sounded like a really probably the best place to do that, to have this impact, especially since OpenAI kind of, yes, it's part of big tech, but it's, because of its structure and ideals. And again, as you can imagine, I was quite skeptical at first, but so far they seem to be living up to these ideas of, really trying to make the positive change with the technology. So yeah, so that's kind of why I decided to, to join. And so what I do is I said, okay, I'm still a technological person, so I wanted to focus on technical things. So trying to, for instance, this data attribution, this, robustness questions, understanding the what these ones are doing. That's kind of, what I'm focusing on. I'm not the only person doing that, but I am kind of providing my perspective on this. And then I hope to also be involved in some way to also channel my experience in policy there. But, kind of that's how it's saying, just saying, okay, maybe it's time to kind of, roll up my sleeves and really try to build AI. Again, given the impact of these products and technology, that's maybe the best way to shape this positive impact of AI here.
So definitely OpenAI will have a transformative impact on the AI landscape, but there's other players and other factors and variables that are going to come into play. I mean, as you kind of look at the next landscape, we've talked about kind of these key issues that researchers and builders should be thinking about, and maybe what are your thoughts on what the GenAI industry will look like in 1 year, and what does the world look like in a few years? So we kind of, based off these variables, what it'll look like in 1 year, but then more of a philosophical point, maybe what it'll look like in a few years with humans co-living with super intelligent systems. What structures, economic, political structures will have to evolve in order to accommodate that shift?
Yeah, so there is this famous saying that it's hard to make predictions, especially about the future. It's again, anyone who observed this Gen AI industry knows this for sure. It's also a lot of very unhappy founders kind of also realize that at first it was kind of seen that the king is okay, we'll have this different products that kind of fine tune the base model and kind of deliver a particular product. Now it turns out, oh no, maybe you just do better base modeling, just does all of that. But now we have an open source models and maybe they're a bit weaker, but maybe you can fine-tune them again. Maybe you will do kind of, all these different philosophies of building, putting things on the mobile or not, like all of this, like, so it's really hard to say. Actually, it may be easier to try to make long-term prediction than the short-term prediction of what will happen, because I really don't know, right? So it's just like a very exciting, but still a mess, like in a sense that actually I like how a lot of innovation and movement there is, because again, there is like, big tech players, there are other startups, there's OpenAI, there's Anthropic, there is Cohere, there is Hugging Face, and all of them have a bit different, sometimes dramatically different idea of like how they want to think about the Gen AI delivery. So, this is the beauty of the market and kind of our thing. So as long as we have the policymakers making sure there's no too much harms, let them just like figure out what will settle. But I think long-term, at least the vision I would like to see is, I'm extremely excited and motivated by this vision of really each one of us having our personal assistant and a personal tutor, right? We all are different. We learn differently. We kind of, we absorb information differently. We kind of, there are all these idiosyncrasies that unfortunately, like the beauty of the educational system is that it can scale somewhat, not fully, but it can scale. But the price we pay is by, we all get kind of, we need to kind of fit into a mold that was developed for us. So I really would like to think of generative AI as a way to completely like, change these trade-offs. Essentially, like now I have a personalized assistant on my phone. I can always ask questions. I can always interact with it. By the way, is the best way for me to learn. And it's customized to me, right? And I don't need to be an MIT professor or someone well off. I can be in some rural areas. I can be in the global south. And I have access. Again, there's a question of economic kind of pricing, but I think we can figure it out. It's just like, I cannot just not get extremely excited about the arm of, again, and I come from Poland, which again, I got great education. So I still had like good opportunities, but like, I can see why we are losing generations of brilliant people who just never get the right education, the right ideas and so on. So I cannot kind of not get excited by this vision. Having said that, I also see other possibilities where kind of it will essentially supercharge the trajectory that social media put us on. And that scares me, kind of like, that's what keeps me going, that I don't want this to happen. So I almost just focus on not making the bad things happen, because I think then the good things will happen, because many people get excited about this. There was the TED talk from the founder of TED Academy that he's working on this Camigo, or I don't remember the name of the bot, but like exactly, it's helping individualized tutoring when they point out the mistake in your solution, but in a way that is like leading, trying to teach you. So I think people will work on that, and I think there's again also a lot of economic value in that, which is all great, as long as we can keep the demons of generative AI at bay, and that will take policy, that will take enforcement, and it will not be easy. Right? Again, like, I want to be very clear. It's just like there is nothing preordained about our trajectory of AI to be the positive one. Again, I'm motivated by this, but I'm not fooling myself that everything will be good. Let's just make what's available to everyone and everything, and we will figure it out. Like, well, we will figure it out, but it's not clear that the equilibrium we'll end up with will be the right.
So first of all, I want to give my takeaway, but Chappie, we've covered everything from his background, his work, his thoughts on policy, some things to take away for the future. I mean, what's your key takeaway as a builder, as a thought leader, in your conversations? What do you take away?
Certainly. So one thing that fascinates me more than almost anything else is how we are going to regulate AI. What is our public policy, our stance on public policy, and how we approach that? One thing I really wanted to learn from you is why is this fundamentally a different problem than our largely successful ability to regulate nuclear, to regulate genetic cloning, and a lot of these other big fundamental issues? And I think you perfectly pointed out that we don't know the full span of risks here. We don't know exactly. We're finding new emerging capabilities in AI every single day, which is what makes it such a challenge to regulate AI. Is we don't know exactly what we're facing here. I think a few examples that you pointed out in your testimony were personalized persuasion at scale. We talked about kind of email phishing and how we can take that to the next level. Automated creation of addictive content. I think that is really becoming quickly an issue. And then I think more broadly, just eroding trust in information in general. Can we really trust what we read on the internet? I'm already running into that issue while going to my YouTube, and I'm not sure if this is an AI generated video or if this is a real video. So it's really getting hard to tell what's real online and what's not. So that's all to say that there are all these incredibly large and important near-term risks to face. But at the same time, you getting to speak personally with the government, with some of these subcommittees, has given me a lot of optimism. And the fact that you have spoken with the government and carry so much optimism, it sounds like there really is interest in bipartisan and even global action here. It was great to see recently OpenAI announced the Super Alignment Initiative, where 20% or maybe it's 25% of compute is going towards solving alignment for these super intelligent systems. So what I take from everything you've said is that this is a really, really difficult problem. There's a lot to be solved here. There are an incredible amount of near-term risks, but we should all carry a high level of optimism. Life and humanity, like to say, has a way of surviving. Life has survived for 3.7 billion years, and so far we have not been wiped out. We're doing well, and there is so much promise here. Generative AI is an incredible democratizing force, and there's really a compelling utopian vision that we can lay out here. So yes, we should be working incredibly hard on solving these near-term risks. These are things we've never faced before. We're not even sure what the full span of risks is, but at the same time, I think we should carry with us a high level of optimism, and it's pleasing to hear that from you.
Sure. So I guess from my perspective, my key takeaway from this conversation is, one, I was trying to piece together what is a common theme on what you work on, and it didn't make sense until about 2 minutes ago when you talked about we want to create structures to prevent the bad. So because we know that most likely there are a lot of people working on kind of the good effects or pushing the technology forward, and not as much focus as there needs to be on capping the downside, if you will. This is something as a researcher, as an engineer, I didn't give a lot of thought to, right? As builders, we're really just focused on pushing the next frontier and what we can build without thinking about the historical context of perhaps the Industrial Revolution, in which, although we had some incredible innovations, we also had a lot of displacement of jobs. We had a lot of displacement of, we also had eroding work conditions, a increase in economic equality. We had, effects on the environment. So a lot of things that we didn't plan for as a society in the prior waves that we need to account for in this wave. So I think, like, if that's the one key takeaway, I think is making sure that engineers, builders are all a bit more careful about how we build and building those systems into our pipelines. So, with that, just want to thank you so much for spending this time with us. It's been completely our pleasure, and we really appreciate it.
Mm-hmm. Yeah, thank you so much. And I just actually completely resonate with your summary. I would just say that it's not just that the builders have to be careful or think about it. I think it's really on the builders. I think we are too much in this mode of operations, like we build the technology, someone else figures out all the rest. It's on us. It's really it's the kind of extreme ownership of the products that we did. But anyway, thank you so much. It was a pleasure to talk to you.
So with that concludes our conversation. Thank you, Collective Nation, if you're still listening. Please find us on our social medias. We're on Twitter, YouTube, and LinkedIn. And you can learn more about the Collective Nation Generative AI Collective at GAIcollective.com. So thank you so much for listening. Enjoy.